Introduction to Organic Chemistry. For the purpose of class, have your record already. So we can start when others come to join us.
Move on, please.
Okay. I'm sure you can hear me.
Yeah, I can hear you.
The noise from the end is a little bit. Okay, so introduction to organic chemistry. Can you see the board clearly, ma'am?
I can.
You can or you can't? I will know how to read this.
I can see it.
Thank you.
Okay.
For this class, organic chemistry is so broad that it cannot be covered in one session or a day, but we'll try as much as possible to touch salient areas which students might be having one or two challenges in. And organic chemistry is broken down into three. We have part one, which they will do in SS1 or book one, as the case may be in technical schools. Or we also have it in SS2, which they also do as book 2, and then SS3 at book 3. So we'll as much as possible to cover the touching areas because of exam fast approaching. So let's see for SS1 what organic chemistry is all about. It's all about petroleum. Petroleum. That's what organic chemistry is all about at SS1 level. Petroleum, and if possible, we'll look at refining of crude oil and the various fractions obtained from crude oil. And also, they are expected to know some things such as maybe cracking, reforming, and octane rating. These are the basics for SS1 in terms of petroleum, what they are expected to know. Then, moving further quickly, can I clean this?
Cracking, refining,
Octane rating. Cracking, reforming, and octane rating. Those are the basics that they are expected to know at SS1.
What's the last thing there?
Octane rating, octane rating.
Okay, octane rating.
Yes. So now, okay, so we can go on. Now, if I ask a very simple question, which you should also ask when you are teaching this area in class, you can ask the student, what is the natural resource that is found in Delta State, since that is where we find ourselves? And I'm very sure they will answer by telling you crude oil. Crude oil is a natural resource, which virtually we all rely on. You can see now they've removed subsidy from fuel and it's biting every aspect of the economy. Today, we are all crying subsidy, subsidy, subsidy. All because the entire the economy has been so reliant on crude oil or on petroleum. So it's one of the major raw materials of what we have been blessed with as a country. And the country now, over time, has neglected other natural resources that we can find, relying solely on crude oil. However, let's quickly look at what is petroleum, in case you want to write petroleum or crude oil. Are you there? Are you with me? Okay, so
yeah, I'm with you.
So by definition, petroleum is a viscous liquid. It's a viscous liquid with unpleasant smell. Petroleum is a viscous liquid with unpleasant smell and has been found to be found billions of years ago. that it? So we can say petroleum or crude oil. So petroleum or crude oil is a viscous liquid with unpleasant smell, which is formed millions of years ago by the decay and decomposition of marine organisms, specifically plants and animals. By the decay and decomposition of marine organisms, such as plants and animals. Okay. If you get that, now having said that, petroleum is a mixture. Remember, you must have taught your students element, compound, and mixtures. And when we say mixture, mixture is made up of two or more substances which are not chemically combined and can be separated by physical means. So if petroleum, we say, is a mixture, that means petroleum can be separated by physical means. And which physical means can we use to separate petroleum? Can you help me out, madam? Just like which separation techniques can be used to separate crude oil. This one can come out in an objective question. The answer is fractional distillation. The crude oil or petroleum is separated by fractional distillation. And why do we say fractional distillation? I believe just a little touch of this. Fractional distillation is a separation technique which is used to separate mixtures based on their boiling point. Fractional distillation is used to separate mixtures based on the principle of their boiling point. But if you check now, we have two types of distillation. We have called fractional distillation and distillation. So both of them apply similar principle, but the underlying difference is that in distillation, the components of the mixtures have far apart boiling points. That means their boiling point is far from each other. Then you will use distillation to separate such a mixture. When the boiling point of the component is far, you use distillation. But when the boiling point of the mixture or the boiling point of the components of the mixture are very close, then we use fractional distillation. Is that it, madam? So it is on these premises that we use fractional distillation to separate crude oil, because the components of crude oil has very close boiling points. And now that will take me to the next thing. What then are the components of your petroleum or your crude oil? Since we said they are very close boiling points. Can you tell me one of them, madam? Components of crude oil or the various fractions from crude oil. Fractions from crude oil. Sorry. Any? Can you hear me? Are you with me? Okay. Are you with me?
I'm with you.
Okay. So I was asking, what are the components of crude oil or the various fractions from crude oil? Because we said crude oil can be separated by fractional distillation. And it is separated by the fact that fractional distillation applies the principle whereby the boiling points of the mixtures are very close. Unlike distillation, the boiling points are far. So let your student know the reason why fractional distillation is used to separate crude oil, because that could be an objective question. Which separation techniques is used to separate crude oil? The answer is fractional distillation. Then, if fractional distillation is used to separate crude oil, what then are the components of your petroleum or your crude oil is my question. Can you help me with one? Kerosene kerosene can be gotten from crude oil. Petrol, diesel. Those are the components. Diesel, yes, very correct. So those are the components of crude oil. And these various components have close boiling points. So let's quickly look at now what are the components of crude oil in a tabular form or the fraction. Let's do this with fractions. If you are with me, you can write down fractions. Number of carbon. Number of carbon. Then here is the boiling point. Or you can just say BP. BP means boiling point, not blood pressure, please. I just wrote that as a short form, but you can write it out in full, boiling point. So let's look at the fractions now. What are those components? The first fraction now is refinery gas. Refinery gas. That's the first fraction. Can you hear me now, please? Can you
hear you?
Yes. Sorry about that network issue. I was actually writing out the various fractions. So the first fraction from crude oil is refinery gas. The number of carbon is 1 to 4, that is between 1 to 4 carbon atoms. Then the boiling point is less than 30. That sign means less than 30. Then the next is gasoline, which is your petrol or naphthalene, between 5 to 10 carbon atoms. Then the boiling point is between 40 to 100 degrees Celsius. 40.
Your board is looking down to my eye.
Okay. Sorry.
The thing is not.
Is it better now? Is it better now?
Okay, I think it's a bit fractions.
Okay, so just you can see, maybe you can hear me. The first one is refinery gas. Number of carbon is 1 to 4.
Number, yes.
Boiling point less than 30. Then the next fraction is gasoline, which is also known as your petrol or naphthalene. Number of carbon atom is 5 to 10. Then the boiling point is ranging from 40 to 100 degrees Celsius. Next is paraffin oil. Number 3. Paraffin oil, also called your what? You can try. Paraffin oil, also known as kerosene. Carbon atom is 11 to, I think that should be 15. Yes, 15. Between 11 to 15 carbon atom, and the boiling point is ranging from 180 to 250. I think is it better now, the board?
Yes.
Okay. So after that, we have the next one, which is light gas oil or your diesel. Now you can just find it as light gas oil or diesel. That's the fourth fraction. Then carbon atom is 15, so it's 16 to 20. There always depends on 5. 16 to 20 carbon atom, then 250 to 300 degrees Celsius. 250 to 300, 16 to 20. And then here is diesel. 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 The fifth one is heavy gas oil, which is a lubricating oil. heavy gas oil. That's the fifth, there's no space. So heavy gas oil. Heavy oil. Number of 20 to 30 carbon atom. C20 to C30. That should be 21 rather. C21 to C30. Between 21 to 30 carbon atoms. Then 300 to 350 is the boiling point. Is that taken?
Yes.
And the
Is it
last
C21?
C21 to C30. There's no,
Okay.
and the boiling point is 300 to 350. Why the last one is asphalt? Asphalt, ASPHALT, asphalt or bitumen. Your number of carbon atoms is just right, greater than, just put the sign of greater than C30. That means it will be 31, 30, thereabout, just greater than that. And then the boiling point is greater than 350. Greater than 350. Any issue with this?
You said the number of carbon is greater than 31, right?
30. Number of carbon atom for asphalt is greater than 30. Then
okay, sorry, greater than 30.
Greater than 30, while the boiling point is also greater than 350.
It's okay.
Okay, so those are the various fractions of crude oil or your petroleum. So we already know that these various fractions are obtained when your crude oil is subjected to the fractionating column, which is the technique that is fractional distillation involves the use of the fractionating column, whereby it is heated and the various fractions comes out based on their boiling point. So it is expected of you to just let the student know that. So can we move on?
Yes, sir.
Okay, so I have a question here. Say list 4 products obtained when crude oil is refined. That's a wide question. List 4 products obtained when crude oil is refined. Who can help us?
Sorry, what's the question again?
List 4 products obtained when crude oil.
List 4 products
obtained when crude oil is refined. List 4 products obtained when crude oil is refined. Who can help us with just the answer?
I think the ones you just mentioned now.
Yes, those ones I just mentioned will be the answer. Then they also add more, says state one use of each product listed. State one use of each product listed. So if you have space under your table, maybe let's just add another column after that boiling point. You can just write uses. Maybe there's a need for also in case the children come across such a question. So after the boiling point, you can create another extra column for uses. Are you with me?
I'm with you.
Okay. So for the first one, which is refinery gas, the use or its use would be, it is used in the laboratory and as a household cooking gas. Obviously, you know that one already. That's refinery gas. It is used in the laboratory and as a household cooking gas.
Refinery gas.
That's for refinery gas, yes. Then why the next one, which is petrol. Petrol, you already know that
Sorry,
one.
can you come?
Sorry?
Can you come again with refinery gas? The uses.
It is used in the laboratory and as a household cooking gas. I mean, we use it for cooking at home. As simple as that. Yeah. It is used in the laboratory and as a household cooking gas. Then for gasoline or your petrol, it is used as fuel in vehicles and generators. It is used as fuel in vehicles and generators. Is that taken?
Yes.
Okay. You can also see add another use for that your petrol. It is used as a solvent for fat and oil. It is used as solvents for fat and oil. What that means is it is used to break down fat and oil. That's why sometimes when oil stains your clothes, if you put a drop or a few drops of petrol and your soap, you simply wash it off because it dissolves or breaks down fat. So that's what I mean by as a solvent for fat and oil. Then the next, which is kerosene or your paraffin oil. It is used as fuel in lanterns or lamps. And that is those in rural areas where they still use lanterns or these kerosene lamps. They know what that simply means. You can also see added also.
Stove.
Yes, even your cooking stove. That is if they still use that nowadays. Then it is another use of it.
They still use it.
Okay. Then another use is that it is used as an aviation fuel for aircraft. Because one very important use of it. It is used as aviation fuels. That means for fueling aeroplanes and your aircraft. Aviation fuels. Any other one? You want us to, obviously, you know what is the use of diesel now. This is also used as a fuel for vehicles. There are some vehicles that use diesel, like all those buses or trains. Then lubricating oil is used in the production of grease and petroleum jelly. Any question? Any question? Okay.
I was asking that's refined gas.
Yes.
Is it not the same thing as natural gas?
No, that's not your natural gas. That's your refinery gas is that your cooking gas at home. That is if you use all this. Like you see during those people who stay in those really houses, you see them flaring gases. And that gas flaring, it's actually wasting of gas. And those gases can be collected as refinery gas. So have I answered your question?
No, I did not get the answer.
You said the refinery gas is the same as your cooking gas, which is obtained when crude oil is being subjected to fractional distillation. So the very first component that comes out in the process of distillation is that your refinery gas. That's if you happen to be within that Ogili or Warri axis, you see gas flaring, you see fire coming out. That fire coming out is the refinery gas which is being burnt off. In developed countries, they will not waste that gas.
Okay.
It can be collected as cooking gas rather than just flaring it away.
So
Yes.
sorry.
Yes.
So which of them now is now the normal cooking gas that we use generally in the
your
house?
normal cooking gas is the gas is that part now which is obtained in the process of refining crude oil. So it's just like you have your petrol, diesel, you also have refinery gas, which is your cooking gas.
Okay.
So that's why you see people celebrating that, oh, thank God, Dangote refinery will also start working. By the time you start working now, you will have gas, normal cooking gas, we have petrol, we have diesel, and those other various fractions in a normal system where the refinery works effectively. Those are the various components you will get.
Okay.
Then that's your asphalt or your bitumen is mostly used in making petroleum jelly. You see some of all these Vaseline, they will say import the petroleum jelly. So those are some of the raw materials which is gotten from in the process of refining crude oil. So those cosmetics industries within the Lagos axis now will be celebrating because they can easily get those their raw material from the Dangote refinery.
It's okay.
Okay, so we can move on now, right?
Yes, sir.
Okay, so the next we'll look at now is cracking. We are looking on to cracking and reforming before we can now quickly move on to the next aspect, which is the hydrocarbon proper. So, cracking. So when we say cracking, what does cracking means? Cracking simply is defined. Are you with me? So cracking is a process whereby large molecules of heavy oils are broken down into smaller molecules. Large molecules of heavy oils are broken down into smaller molecules, in brackets, light oils, at high temperature and pressure and in the presence of catalyst. Process whereby heavy oils are broken down into lighter oils at high temperature and pressure and in the presence of a catalyst. That's what we call cracking. Are you with me? Can I move on?
Just take it one more time before you move on, please.
Cracking is a process whereby heavy oils or large molecules of hydrocarbons are broken down into smaller fractions or lighter oils. Heavy oils are broken down into smaller fractions or lighter oils at high temperature and pressure and in the presence of a catalyst. So in case you have students define cracking, that is the definition of cracking. Then we have types of cracking. Types of cracking. Now remember we said cracking, breaking down of large molecules of hydrocarbon into smaller fractions in the presence of a high temperature, pressure, and then catalyst. Okay. So these three things are the basis for the types of cracking. So we have the first, which is thermal cracking. Catalytic cracking. And one very one is now the hydro cracking. Hydro cracking. This one is rare. Most at times, the most common one are just these two. Hydro cracking. And so the three types of cracking are thermal cracking, catalytic cracking, and hydro cracking. So for thermal cracking, just the word thermal, let them know, simply means heat. Catalytic from the word catalyst. Remember cracking already, which is breaking down large or heavy oils into lighter oils. So that simply means thermal cracking is the breaking down of heavy oils, such as your lubricating oil or your diesel and kerosene, to lighter oils in the presence of heat or under high temperature and pressure. That is thermal cracking. Involves heating heavy oils such as lubricating oil, diesel, and kerosene to about 600 degrees Celsius. So the temperature is 600. So you can see very high temperature to about 600 degrees Celsius, and pressure to produce or to form lighter oils. So that is thermal cracking. So in thermal cracking, you could have heavy oil, such as, let's say, for example, I have kerosene now, which is between C11. I want to say C11, so C11, 11 times C11, H28. If it's broken down, to give me C5 or C8 rather, C8, H18 plus, now this how to go about it, very simple. Take away this 8 from 11. So in case they give them, they can ask something like this in the exam now. And ask them what is X. How do you know your X? Is not so difficult. Subtract this 8 from 11. So that X now to be C. I'll give it 3. Take away 18 from this. I should be having 10. I should be having 10. But this is maybe 8. H6. So let's do 6. This is supposed to be 4. Plus 6 times this is 6 plus this is 24. This is 24. So it's C11, H24. When broken down, we give me this. So this is kerosene. And this is petrol. And this compound is an alkene. An alkene. Specifically, if you want to go by the name, that is 3 carbon atom, which is propene. If you want to go by the aliphatic name, is propene. But just know that this is cracking, thermal cracking, because broken down the heavy oil, such as kerosene, to a smaller oil or a lighter oil, petrol. And in the process, I have an alkene as a byproduct. So this is cracking, but specifically thermal cracking, because it involves heating this kerosene at a very high temperature to give me petrol. So one important aspect of cracking is that cracking helps to improve the quantity. It is so that when you have a high demand for a particular fraction of the crude oil, you can subject one of the lesser demand, the one of lesser demand, under cracking to give you the one with the higher demand. You know, if I ask now, petrol and kerosene, if I put both of them down now, people will rush petrol, leaving kerosene behind, because we already know the use of petrol, which cannot be compared to that of kerosene. So petrol, which is of higher demand than kerosene, can be gotten from kerosene by cracking. Because we are short of, I think I have less than how many minutes to go for this class? Less than 3 minutes. So I will stop here. When we hook up again in the next 10 minutes, we'll continue with catalytic cracking. Catalytic cracking. That will be the next aspect that we'll quickly look at now. When in the next 10 minutes, when we come back on board. So let me just round it up at this point for now. So this, take note of this. This equation is for thermal cracking. Thermal cracking. Right. So that is what this figure is all about. So let's shut down this first session and to come back in the next 10 minutes for the other part. Thank you very much.